So method call chaining. We have been writing all of our setters to return void. And if you write them to return void, you can't do this. And if you really wanted to do this, you'd have to make them do something else. You'd have to make them return the this reference. So, you have a car, set make, Toyota, followed by another call, set year 2014. And I suppose we could keep chaining calls like that, whatever we wanted to do. To get that to work, what you got to do is return the object's reference to itself, to return the this reference. And so method call chaining is when you use a dot to concatenate a method to the end of another method call. So let's make a silly class just to demonstrate that. Maybe it's all it's going to have is a number, and we're going to be able to call like double on it to double that number, or triple to triple that number. So if I'm not wrong, we're on lecture E. I didn't call it lecture E, my mistake. Clean up some of the extraneous comments. Now what am I going to do? I'm going to declare a class. I'm just going to call it num, because all it's got is a number in it. And inside it, it's going to have a variable. Why not make it a double? I'm going to call it value. And maybe we'll just initialize it to being equal to 1. Now I want to write a method that will double it and a method that will triple it. So when we call it, value will be multiplied by 2, or value will be multiplied by 3. So what we've done in the past, if it's something that doesn't need to return a value, we would declare it as void. I'm going to call this one double me. It doesn't need to take any parameters. And what does it do? This dot value times equals 2. And then triple me is going to do the same thing, except multiply by 3. Right? So void triple me, parentheses in parentheses, this dot value times equals 3. So down in main, I could create an object, num in1 equals new, num, capital N on the word num, because that's the name of our class. And if we wanted to double it, in1 dot double. If we wanted to triple it, okay, excuse me, in1 dot double me. There we go. If you wanted to triple it, you could call in1 dot triple me. And if we had implemented call chaining, which we did not, you'd be able to do this. Call double me dot triple me. Like that. If we did that, I wonder which one would get called first. Would double me get called first and then would it call triple me? I believe so. We could put print messages in here to find out, or we could use the debugger to find out. But it's forbidding this right now because we have declared these methods as being void. And you can't do call chaining with void methods. What we would have to do is we would have to replace these words void with the name of the class, which is NUM. So if I took this and I replaced that with the name of the class, and I took this and I replaced it with the name of the class, now it's complaining because I don't have any return values. So to each method, I'm going to return this. That's going to be the statement, return this semicolon. Like that. And now this does work. And I'm curious about when this happens. Does it run double me first or triple me first? And I'm 99.999% confident it's going to run double me first. But how am I going to find that out? After I build it, hammer and broom it, I'm going to set a breakpoint on both line 10 and on 15, or whatever they are on your, if you didn't delete your comments and everything exactly right, there'll be different line numbers. But I'm going to set a breakpoint, which means just I'm going to click on that number 10 and it marks it red. I'm also going to click on this one right here, click on that line number, it marks it red. And then when I run a debug mode, debug this project, it'll stop when it gets to one of those lines. And it did stop at the double me call, which makes sense because double me is being invoked right first in the chain. And so if we step through the debugger past that point, it blips back down to here, and now it's going to call triple me. And now we're in triple me. And we can keep stepping over and it'll come back out. And now the program is done. We need to do a lot more in the debugger. The more skilled you get using the debugger, the better off you are. So that's call chaining. I can't really think of a lot of times I've ever wanted to use call chaining. Not once in my professional career as a programmer before education. So no, I have no idea why I would do that, but I guess it's kind of cool. I guess it's kind of cool to be able to link up your calls like that. Honestly though, I think I would have been just as happy doing this, right? Calling double me on one line and then triple me on the next. I think that would have made me just as happy. But since I have the ability to chain these calls together, I guess I'll do that. Now I'm going to remove my breakpoints so that they don't accidentally catch any other time I debug it, although I usually don't run in debug mode. Usually I run it in run mode. And it says it's currently running, so I'm going to stop it by clicking that. All right, now it's gone. One thing I want to caution you against, and I had some students text me with messages over the weekend trying to work on this, is don't create your calls to the object before you define the calls in your object. And what do I mean by that? Well, I may want to add something else, like an n1.add, right? And it's going to take a 3. Okay. Well, that's messed up. What do I want to do? Well, there's a couple things you could do, but one is you could come up here and you could add an add method to it. And so maybe you'd declare it, and you'd call it add, and you'd get mad because it's not working. Well, there's a couple reasons why it's not working. Why is it not working?
You capitalized it.
I capitalized A there, not there, so I could fix that. That'd be a great thing to fix. It's still complaining. It's because it requires no argument found int. And so then I'd have to go and I'd have to, add that in there. And anyways, really, really, really write your methods first and then write the call to them. That being said, there is a style of programming, and I don't recommend you do it this way, but you can, where you kind of stub out how you want it to work like that. And then you click on the red arrow and you say create method. I strongly, 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 strongly encourage you to not rely on ever clicking create over here. If it wants to add an import for you, sure, that's great. If you want to click and create something like that, then no, you're in bad territory. If I come over here and one of the offers is to create a string class in my project, that would be the absolute wrong thing I would want to do. And there already is a string class, and if I create a string.java file in my project, then your project is going to stop working, and it's going to make you very confused, and it's going to make your prof very confused when he's looking at your code, sending me pictures and stuff like that. So anyways, but that said, I could do this. I could say, okay, I need a method called add. I know I need it. So I'm going to do that, and I'm going to click the create button, And if I do that, it does come up, and it takes the best guess, bless you, as to what needs to be passed in there. In this case, you know, it looks like an int is sufficient. It takes the best guess as to what its return value would be, and it puts this in there just to indicate that the code's not really done yet. If we ran it, right, it'll blow up at that point. We'll get some red text in our output window. Like that. So it didn't finish the job, but got us going, right? Anyways, please define your calls first, because once you define your calls, then it's easy to write the code that uses them, right? Now that double me and triple me have already been written, I can just do n1 dot double, and I can write, it's already prompting me, right? And I know that it doesn't take any parameters and whatever. So write the data object first before you write the client code. So to do method call chaining, the return type of the method has to be the same as the class name so that it can return this reference. So the name of this class is car3, so this method that they wanted to be able to chain, they made its return type car3 so that they could return to this reference. They did the same thing for set year. Now I could see conceivably making all of my setters like that, because it might be kind of neat. I'm just kind of thinking out loud here. But if you had some point class that had point X and point Y and point Z, now this isn't going to even work, right? But if I had, you know, some point class and I could do set X to 10, don't bother taking a comment unless you didn't really want to, because I'm not going to write the class to support it. Set Y, you know, to 3 dot set Z, you know, equal to -1. Now that's kind of cool in a way. I might want to start making my setters so that they are chainable. If I wanted to do that, well, let's add a setter to this num class. We have one value here, and I did demonstrate to y'all that y'all can cheat and just let the refactor do it, or you can write it yourself, right? I'm going to write it myself so that I can make my setter actually return this reference. So public, and I haven't been making this thing private and these public, and I should have. Right, public set value with a capital V, double value, and so what we're going to do is this dot value equals value semicolon, but I want the return type of this to be the same as the class, so I'm going to make it say public space num, capital N, space set value. And then the bottom of the method has to return this. And if I had other setters, you know, then it would actually have made sense to chain them like that, because I could set the X and set the Y and set the Z and whatever all in one call. So with it like that, if I so wanted to, I could do something dumb like this. n1.set value 10 dot set value 20, right? Whatever. I mean, it's a callable, it's a chainable method. Now that's silly to set it to 10 and then set it to 20, but we could set it to 10 and then we could triple it, right? Then its value would be 30, or so on. That's about enough about call chaining. I'm warming to the idea of making all of my setters chainable if I have a bunch of them. Method call chaining is optional. Why bother with it? Does he give us an answer to this on the next slide? No? Okay. Well, I don't know how to get the answer to that. Method call chaining is optional, so why bother with it? I would only bother with it if it makes the code easier to write or to use. So overloaded methods. Overloaded methods when you have more than one method with the same name. And we probably ought to write a better class than this num class. This num class, meh. Not really feeling, well, actually we can keep going with it, right? We have something called set value that takes a value. Let's write something that will accept an int and add it to it. Or, yeah. So, I guess we could keep going with the same idea. No, I'm going to revert back to habit. Void, add, and we're going to take an int and add that int to our value, right? So this dot value plus equals x. That means down in my code I could call the add method and I could pass in an int. But what if it needed to be a double? Well, there's two fixes really. But one is I could write another version of the method that would accept a double. I would have two versions with the same name. And it would work. It's not an error to have two methods with the same name. Void add, which takes a double. And this dot value plus equals x. Well, now that I have this one, I don't need this one anymore, to be honest. Because an int will get converted to a double if need be anyways. But it's an example. We now have two methods with the same name. So down here, after we create our object and we wanted to add some value to it, we could do n1.add 10. And then we could do n1.add and pass in a double, right? Like that. Either one works. Like I said, if we're writing a method that accepts a double, it's probably not necessary to write a separate method that accepts an int, unless its behavior is different. Because even if we didn't have this method here, even if I deleted it, the code would still compile. Because a 10 can be converted to a double just fine. But the reverse is not true. If I deleted this version of the add method that was a double, then this call is wrong, because it won't convert a double to an int automatically. Unlike C++, which is idiotically happy to do things like that. Why do I say it's idiotic? Because to convert this double to an int, it would have to drop the 0.6, right? We're losing data. And so it's a good idea to make the programmer realize that they're going to lose data when they do that. So let's come up with another example. Let's write a pair of functions, and I'm going to just write them right above main inside my what I should have called lecture E. I did not call this lecture E, but I feel like renaming it. So I'm going to highlight that class, come up to refactor rename, and rename my file to lecture D. This is just to show you that you can. If you need to rename a file, it's pretty easy. All right, so we're going to write a function that will add two numbers together and return the results. So public static int add. And it's going to take two numbers, int I1, comma, int I2. And what does it do? It returns I1 plus I2. So when I play with it, I could do this. Int x is equal to add 10, comma 20, right? But what if I wanted a version of add that would then accept three variables? Because later on, I want to be able to say x equals add 10, 20, 30, right, like that. I want to be able to add three numbers to it. I just need to rewrite this. I need to put another version of add that accepts three parameters rather than two. The easiest way to do that would be to do some judicious copying and pasting. I could take those 4 lines, copy them, paste them, and add on a comma int I3 to that line. And then I'm going to have to change this line to add plus I3 there. So now it works, right? We can call either one. And we could write another version that had 4. Now what if you wanted a version that would be able to accept 2 strings and add them together? Like x is equal to add 1 to 2. We'd have to write a version that would have strings as its parameter variable types. And it would have to convert from strings to floats, to numbers, so that they could be added. That's hard. I don't really feel like doing it. I mean, not that it's that hard, but why don't we do something a little bit easier, which is to make a version that accepts doubles, right? So add 3.5 to 5 whatever, right? Now this isn't working because these are doubles and it's expecting ints. So I could write a version that would add 2 doubles and return a double. Then it should not be stored in this x variable because that's still an int. I would want to declare a different kind of variable to hold the result. Double D equals add that and that. Now I'm kind of breaking the law about what I said about writing the method first before you call it. Yeah, well, public static double add double D1 comma double D2 in parentheses return D1 plus D2 like that. And I could write one more version of this that took 3 doubles, and so on. So why would you bother doing this? Why would you do overloading? What would the alternative be? If we were not allowed to write methods that had the same names, you'd probably come up with some naming nomenclature like this. Well, this is add 2, don't type this. This is adding 2 ints. This is adding, and I'm gonna delete these immediately. This is adding 3 ints. This is adding 2 doubles. This is adding 3, right? That makes it harder to use. Yeah, the names make sense, but you can't just go, oh, well, I'm going to add 2 numbers and then pass in whatever numbers you want, whatever kind of numbers and however many that it's been written to accept. Right? It's much cleaner to be able to have the same name if the methods are conceptually doing the same thing. So as promised, I'm undoing those changes. So here's their example. I guess I should bring the code back. I hear people still typing. So overloading, not bad. Not like, oh, Captain, the engine's overloading. We're in trouble. Overloading equals multiple methods with the same names but different parameter lists. This is the key thing. You can't write 2 methods that have the same input but return 2 different outputs. What do I mean by that? I'm going to make a copy here and paste it, but I'm going to immediately delete it, so don't make this copy. But what if I made one version of add that took 2 ints and returned an int, and then I made another version of add that took 2 ints and returned a double? Well, it would complain that that was an error. Why? Because when we called it, how would it know which version was being called? And we say, well, you're storing it into an int, it would call the int version. No, because all of this happens first. You don't even have to store the results of a method call, right? That's not a syntax error. It doesn't do anything useful because it doesn't store the result in a variable, but it's not a syntax error. And so when we looked it up, okay, I'm going to be calling something and it's got 2 ints. Well, 2 of them match that category, right? The compiler wouldn't know which one to call. So you can't write 2 methods that have the same parameter list but differing only by the return types. Instead, the parameter lists have to differ. So that was a mistake. I'm going to delete that. And you overload in order to make the code easier to read or to write or to use. I mean, from a programmer standpoint, you're using your class. You are the user in that case, or another programmer is the user in that case. I need to undo all the changes I did. There we go. Sorry about that. Hopefully yours is already like that, because I was telling you not to make the changes as I did. So suppose you're writing software for an alarm system that uses a word, a number, or a combination of words and numbers as a password. To activate or deactivate the alarm, your program needs to call a validation method that checks the passed-in word or the number or the combination word and number. And so you could write 3 different methods. Validate using word. Validate using a number. Validating using a word, then a number. And then validate using a number, then a word. Well, that's just silly. Instead, you would just write one method named validate, and you could pass in a string, or you could pass in a number, or you could pass in a string followed by a number, or you could pass in a number followed by a string. Right. If you needed that many different versions of it, you could do that. So the better solution is to use overloaded methods. You have 2 or more methods with the same name but different parameter lists. Either different numbers of parameters or different types of parameters, or both. So you could write 4 overloaded validate methods. Validate, it had one name, and it didn't care if you passed in a string or a number, or a string and a number, or a number and a string, and it would still do the proper validation. It would hook it up to the appropriate method and call the appropriate one. So set height. We've written a class called height. We have a value and a unit of measurement. And so if we call set height and only pass in a value, but don't pass in the units, it defaults to being centimeters. But if we call set height and we do specify a unit, so not only does it set the value of the height, it sets the units. So we have 2 different versions of the set height method. One that accepts only the numeric value, and the other that accepts the value and also sets the units. So you can call one overloaded method from another. If we have this set height method that doesn't accept a string, it's okay to then turn around and then call the set height method that does accept a string. Because if you went to all the trouble of making that other method, it may be perfect for what you need, and you're just kind of going to make a custom version of it that doesn't need that value, and if it is, it defaults to that. So a constructor. Up to this point, we've used mutators to assign values, which works okay, but requires you to have and call one mutator for each instance variable. As an alternative, you can use a single method to initialize all of them. You could write like an init method that would allow you to initialize the 3 important pieces of data for your car in this case. And that's fine. But maybe you also want to make it so that you can specify those values as you're creating the object. So why might we want to do that? Well, I mean, hopefully it's pretty obvious. I'd rather not have to do Ashley car equals new car and then Ashley car dot set year 2012, Ashley car dot set color chartreuse, Ashley car dot set model. I would not want to have to do 3 of them in a row. And sure, maybe I did call chaining, but anyways, it's a lot nicer to be able to specify all the different values, or at least a large chunk of them, with a single call. And if you're going to do that, then why not make it so that you could create the car and set all those values at the same time, like that. And for that, you can use a constructor. Well, let's go and we kind of did a point class that had an X and a Y component. Let's go in and make a class called fraction that has a numerator and a denominator. So way up above my num fraction, I'm going to do class fraction. And I'm going to try to be a good programmer on this case, so I'm going to make the variable's private. Private int numerator, private int denominator. And here's how I want it to work. I want to be able to do this. Fraction f equals new fraction 1 over 1 comma 2. And that would equal the fraction of 1/2. That's how I want it to work. But I'm going to have to make a constructor that will accept two ints, a numerator and a denominator. I guess I could have just called it top and bottom, right? So a constructor is a class, it's a method that has the same name of the class, but no return type. Well, let's do that. Your method should be public. So public fraction int numerator, int numer, comma, int denominator, int denom, and we set this dot numer equal to numer, semicolon, and this dot denominator denom equals to denom. Except I spelled demon there. That was not my intention. D-E-N-O-M. And now if I put this line of code into main, it would actually work. What kind of warnings are you giving me here? Probably that they're set but never reset, never changed. Well, if we wrote something that changed them, then those warnings would go away, so I'm not going to mess with them. So what can you do with fractions? You could calculate the value. Right? Get the value. Now that we've created a fraction named 1/2, and calculate it, and it would tell us 0.5. What is that doing? It's just returning the numerator divided by the denominator. But since these are both integers, we'd have to make sure that it did not do integer math, because 1 divided by 2, rounded down, is 0. So we'd have to be a little bit careful. But let's go ahead and write one called getValue, and it's going to return a double. So public double getValue, parentheses in parentheses. And so double result equals numer, semicolon, or this dot numer. Really kind of wish I'd gone with top and bottom. And then result slash equals this dot denominator divided by the denominator, and then return result. Why did I make it a several step process? Because I wanted to store it into a double before I did the math. Because if you just have two numbers that are integers and that you ask it to do math on it, like if I did 4 divided by 3, don't type that, I'm going to delete it. But 4 divided by 3, when they're both integers, it's not going to be 1.333, it's just going to be 1. And so if I created a fraction that was 4/3 and I told it to give me the value and it told me that the value of 4/3 is 1, I would be unhappy. So we're storing one of the variables in a double so that we could then get the result of it. And there are other ways to do that, but I think that's okay. I think I'm happy leaving it like that. Now what if we created a fraction like this? One where we said like that. But when we called value, get value, maybe we want to get the simplified version of it. Well, to get the simplified version of it, you'd have to calculate the largest common factor, right? The largest common factor of 2 and 4 is 2. And then you could then you could divide both the numerator and the denominator by that value in order to get it to work. I'm going to just leave that idea tucked away in the back of our heads. But we may as well use our fraction class. So if you've got this going, why not go down to main? Fraction f1 equals new fraction 2 comma 3. And let's just print out that fraction. System.out.println parentheses quote f1 value equals end quote plus f1 dot get value, parentheses in parentheses in parentheses semicolon. I seem to have a compilation error that it's warning me about. Maybe it'll go away when I click the build button. Yes, it did. Okay. All right, and kind of as predicted, 2/3 would in fact be 0.66666 when displayed. So why would you bother with a constructor when you could, and this would not work because we do not have setters, right? But we could have done this instead if we did, right? And like I said, don't type this. Set numerator to 2, right? f1 dot set denominator to 3. It's just easier to create your variable like that, right? To do it in one step rather than have to create it and then set those values separately. If you want to set the values separately, then it'd be a good idea to go ahead and add setters for them. And you know how easy that is. We've already seen it a couple of times, but I could just highlight those two guys and refactor, encapsulate, and let them create 2 setters and 2 getters for them. Wouldn't be anything wrong with doing that. Or writing them myself. To set the numerator, what do? Public void set numer with a capital M in, and take a value, int numer in parentheses, and just set this dot numer equal to numer. And I could do that for the denominator as well. So it's a considerably larger project that I would want to talk about in just 5 minutes worth of lecture. But it would be neat to write a fraction class where you could then do something like this. I'm just going to put in a comment and delete it, so don't type it in. But wouldn't it be neat if I could do this? You create 2 fractions, and then you could say f1 dot add f2, and it would add that second fraction to the first one, right? Or f1 dot multiply f2, and it would multiply f1 by f2. Now that'd be pretty neat. It would not be that difficult to do. But one of the things we would have to resolve is the simplifying of the fraction, because eventually you're going to wind up with 25/50. And you shouldn't be carrying those numbers around if you could simplify them to being just 1/2. Is anybody getting compilation errors that you wish? All good? Okay. So Constructor lets you specify what happens when the object is instantiated with the new keyword. It's called automatically when the object is instantiated. The constructor has the same name as the class name, but it doesn't have a return type. Constructor is a method with the same name as the class with no return type and is invoked by the new keyword to make a new object, or to instantiate a new object. That's what a constructor is. So the example car class with a constructor. We made a car. Apparently we aren't specifying how the class looks. We're instead looking at how it would get used. I'm going to make 2 more cars. This is version 4 of the car class. And here we go. Get to set all 3 variables as we make them. And here's the version of it that supports that. Our class has 3 instance variables. And so its constructor sets the make, the year, and the model. You can also add a default constructor that lets you call it without passing in those values. Because now that we have that constructor, we would not be able to do this. We would not be able to say car4 z equals new car4. The fact that it has a parameterized constructor prevents this from working. Python, Java gives you an automatic default constructor. Python doesn't, so I don't even know why the word Python came to my head. Java gives you a default constructor that makes this work, but as soon as you add in a parameterized constructor, one with parameters like that, the default constructor is no longer provided, and if you want it, you have to add it there yourself. So let's say that's the case. We'd want to go back to our class and add a default constructor. So if this is the constructor, I'm going to add a comment to that effect. This is a constructor, but I'm going to add a default constructor which isn't going to do anything except maybe set the values to 1. 1 over 1 sounds like a good default constructor value. Public, fraction, and no parameters. So parentheses in parentheses. And we set this dot numer equal to 1, semicolon, this dot denominator equal to 1, semicolon, like that. That way our code can create a fraction either way. It can create one and set the values together at the same time, or it could just call the mutators, of which we've only done one. It's bugging me that we've only just done one. I feel like adding the other while I'm looking at it. So I'm going to copy the set numer, and I'm going to change it to a set denominator function. So I'm just going to copy that one, paste it, and then change all those numers to denominators in the copy. Now what have I done wrong? I'm sitting here feeling real proud that I've changed all the numers to denominators, but it's still telling me that there's a problem. It's supposed to be a set denominator, and I left the name set numerator. That was pretty dumb. So there we go. I had to change it in 4 places. I had to change that one, that one, that one, and that one. So let's add the fact that this is a default constructor. A default constructor is one that accepts no parameters. Doesn't take any arguments, so it doesn't have parameter variables defined. Since I've added that, then it's legal for me to go and do this. Fraction f2 equals new fraction, and not set the values. And then I could set them separately, right? I could say f2 dot set numer to 2, and f2 dot set denominator, set denom to 4, right? And I could print its value out as well if I cared. In which case I would probably copy this and paste it and change the f1s to f2s. So change that f1 to an f2, that f1 to an f2. So the first fraction that prints out is going to be 0.666, and the second one is going to be 0.5, because 2 divided by 4 is 1/2. All right, seemed to have worked. You don't have to go and add a default constructor if you don't want to, once you've added a parameterized constructor. If you want them to always have to fill in the values as the object is created, that is a legit design decision. So anytime you create an object with the new keyword, there has to be a constructor that matches. What does that mean? It means I could not create, don't type this because it wouldn't work, a fraction like that. Why? Because there's no constructor that accepts only one variable. There's one that accepts two, there's one that accepts no arguments whatsoever, but there's none that accepts only one. And we could go back and add one that did that. And maybe what it would do is it would assume that the denominator was a 1. So if you tell a fraction of 10, it assumes it's 10 over 1. It's a reasonable thing to do, so we could perfectly well go and create a constructor that accepted one variable. But right now it doesn't. So since there's no matching constructor for this to call, it won't let it compile. That's a syntax error. So until recently, we've instantiated objects without using an explicit constructor. Were those examples wrong? No, because the Java compiler does give us an empty-bodied zero-parameter default constructor, but only if the class contains no explicitly defined constructor, what I was calling a custom constructor or a parameterized constructor. So the next slide shows a class with no constructor. And so it does have that default constructor. You can create an employee based on this. Just doesn't have the constructor there in front of us. If we wanted to add it, we could. We could say, public employee, right there. There's the default constructor. But we don't have to do that. Java's giving it to us automatically. So an overloaded constructor is when you have two or more constructors with the same name but different parameters. Now I just mentioned that. In our code, we could have written a constructor that would let us pass in two variables, or none. We've already overloaded it once, but maybe we'll overload it again so that that actually would work and we can pass in just one value and the other one would be set to 0. Set to 1, right? So if we pass in 5, it'll assume 5 over 1. So let's go and add one more constructor to it to do that. Going back to my fraction class, here's one of my constructors, here's another one. I think the easiest way to create this fresh one would be to copy this one, paste it, and then just change the denominator. Remove that denominator parameter. Or I could just type the whole thing in again. It doesn't take that long. Yeah. So public fraction with capital F, int numer, in parentheses. And that sets this dot numer equal numer to that parameter that's passed in, but this dot denom is set to 1. So now we have 3 different functions, 3 different methods with the same name. And that's okay in this language. It doesn't work in Python. Python won't let you create multiple methods, multiple functions with the same name and then pick at runtime or compilation time which one to call. Certainly works fine in C++ and Java, so no reason not to take advantage of it. So right now we have 3 constructors with the same name, but they differ by their parameter lists, and that's fine. So if you want to, you can call one constructor from another if you want to. I didn't necessarily have to write it like this. I could have written it like this might actually just make it more complicated. But see here, when we call the default constructor and we're just setting both values to 1, I could have just said like that. Or not. Give me an error. That's giving me an error too. Maybe I'm not going to work too hard at getting this to work. But here's their example of it. Oh, what do you know? They're working on a fraction class. Numerator, denominator, and quotient. But they've written a version of the constructor. Oh, it's the this keyword. Derp. I knew that. Don't know why I was. So we could say a fraction with no parameters is the same thing as creating a fraction with 1 over 1. And we could say that a fraction with one parameter is the same as creating a fraction that has a numerator with the denominator set to 1. I don't know if you think that makes the code easier to read or harder. If you liked it better the other way, that's totally fine. But I will add that as a comment, though. To call one constructor from within another, use the this keyword followed by parentheses and arguments necessary to call the other constructor. Only thing though is that this has to be the first line of code in that constructor. If I thought that, oh, I could create a new variable, you know, this dot denominator, and don't do this because I'm going to have to delete it, right? And then call the constructor, it's going to tell me that I can't do that. The call to the constructor can only be the first line in that constructor. So that did not work. So the call to this constructor must be the first line of code in the constructor you're writing. But maybe looking at this example, it makes kind of sense. This is the cool version of the fraction. This version of the fraction takes, you know, the top half and the bottom half, and so the other versions of the constructors just need to call that function, right? Call that method. And so when you're passing in only in one number, the second number is assumed to be a 1. Or if you're passing in no numbers, then we're assuming that both of them are 1. I think that makes sense. I like the way it's written. Hope it makes sense to you. All right, sometimes you'll want to make an attribute to be fixed, to be a constant. What does that mean? That means that as soon as it's created and set by the constructor, it never changes. So I don't even have an example of why that'd be a good idea in the fraction class. But if we wanted some kind of special value of the num class that once set would never change, we would declare it with the final keyword. So let's say that each number has a name. And we could do that, but it's complaining because we haven't given it a name. We don't have a default constructor that sets the name. We don't have any constructors in here. So if we were going to do that, we'd have to add a constructor that would set that value. What's a constructor? It has the same name as the class. So public num. And it would set this dot name equal to whatever, Fred. And it could set this value equal to 1, something like that. Now I've kind of goofed it up. I'd rather this double value equals. I don't like the construct. I like for my variables to be at the top of it, so I'm just going to cut that one. and paste it above there. Right. And if I'm giving a default value in here inside the constructor, I don't need to give it there. So I'm going to remove that one. All right. So now nothing can ever change the this reference. Excuse me, the name reference. The fact that it's been set as final means that later on nothing could change it. I can't go down here, and since I can't, don't do this. This dot name equals Bob. It'll tell me that that's not something I could change. It'll underline it. The book wants me to capitalize this. The book says that I should capitalize that. If it's a constant, if it's a final, it should be capitalized. Okay, sure, why not? If you have an object that once created, none of its values are going to be changed, you could mark the whole class as final. Like imagine a fraction that once you created, you can never change its value. If that was the case, if we were going to make such a thing, which we didn't, we would have stuck the word final here, like that. Now that's not going to work, because we have things that change its values, I believe. If I try to compile it, that should generate an error. Please tell me you generated an error. Well, since it didn't, I'm not going to talk about that any further. How about that for ducking the subject? So why is name in all caps? I'm creating an instance of a named constant, normally called an instance constant. Why is it an instance constant? Sure, I wish I had the answers for these little philosophical questions that they ask. That's okay. Well, it's a constant because it's constant only for that specific variable, right? You create that num and you give it the name Fred. After you've done that, that guy's name can never change from Fred, but you could create another object and set its name to Bob. And once that thing's name was set to Bob, it would never change. But it's just like an instance variable. It differs instance by instance, but it's a constant variable, right? It can't be changed once set. So that's why it's called an instant constant. All right, let's see here. So if you did not do homework 2 because you didn't understand constructors yet, this is the chapter that handles constructors. So certainly go back and do homework 2 now. Don't skip it. I'll let you turn it in late because we covered the topic in the lecture before we covered it in the PowerPoint. So please go back and get homework 2 done if you have not gotten it done already. So let's make up a UML for another class. It's going to be a UML for tracking vet information, whether somebody has been vaccinated or not. So we're going to create a class called pet, and I'll upload these. You absolutely do not have to type these in, but that's the name of the class, right? And it needs a couple pieces of data. It needs a name, which is a string. It needs a birth date, which is a string, and a vaccination date, which is a string. And we're going to need getters and setters, right? So add all the getters and the setters. Get name, set name. I will go in and flesh this out to be, correct. Get birth date, set birth date, and then get vac date and set vac date. So let's have a default constructor in it. So we'll need a default constructor, just called pet, that doesn't do anything, right? That's the default constructor. But also add a parameterized constructor, a custom constructor, an explicit constructor that will allow the name, birth date, and vac date to be set all at the same time. So what would that probably look like? It'd have three variables, right? It'd have a name variable, a birth date variable, and a vac date variable. And then lastly, you would need a display method that would print that information out. The display method should print all the data out about that pet. In other words, it should print the name, the birth date, and the vac date. So your code should create two different pets, one using the default constructor and three setter calls, and the other using the custom constructor, the parameterized constructor. Call the display method of both objects to display their data. That makes sense? Hopefully you remember what UML is. When I go back in, I will be specifying what data types these things are supposed to return. Since get name is a string, it returns a string. Since set name doesn't need to return anything unless we were going to make it chainable, we would call it void. Same for get birth date. Birth date's a string, but the setter doesn't need to return anything. The vac date is a string. The setter doesn't need to return anything. And this is void because it doesn't return anything. That making sense? We're going to be able to get that done in a weekend? Yeah.
I don't know what UML means.
Stands for Unified Modeling Language. It's in Chapter 6. Go back and look in Chapter 6. But basically, it's just, what is UML? It's a way of describing the class. If we go and we look at our fraction class here, and that is a very good question. And I hope I didn't stop the recorder yet. All right. Here's what our fraction class looks like. It's got two variables, and it's got some setters and stuff like that. So here's what its UML would look like. The top line is just the name of the class. Then the next block is a list of all the variables. So it's got a int that's called the numerator and another int that's called the denominator, right? And then the bottom block of the UML is a list of all the functions. And we had several functions. We had set numer, set denom, and we had some customized constructors. But anyways, set numer returned nothing because it was declared as void. But it accepted a value that was an integer, right? It accepted a variable called numer that was an int. And set denom looked exactly the same. Like that. And it had three different constructors that I would list here as well. So why not list them? We had a constructor that didn't accept any values. So it was just called fraction, and it didn't return anything. And we had another one that took a single value. That was an int, and we had a version of fraction that accepted two ints as parameters. A numerator and a denominator. Like that. And so that's the UML diagram for this. Universal Modeling Language. The UML diagrams can get a lot more complex than this. Now, when you're creating a UML diagram, you should be specifying whether the members are public or private. In this case, I made the data private, so I should stick minus signs in front of it. And I made all of the methods public, so I should stick plus signs in front of all of them. Plus meaning that those are public, minus meaning that these are private. Does that make sense? It's a shorthand for describing what the members of the class are going to be. Good?
Mm-hmm.
All right.
Can I see the bottom of this code real quick? The homework.
Yeah. All right, the Dropbox is already there, so feel free to upload whatever you need to in it. And see you next lecture.